So here we go. Welcome, everyone. Let's get going. So looks like folks are in the space. I'll put the link to the resource page one more time and we'll get started. I'll just introduce myself real quick. Happy to be here with you all. My name is Rebecca Garelli. I'm a professional learning specialist with Activate Learning. And I am here for this snapshot webinar on student sense making. So remember, since this is a snapshot, this is just going to be a high-level overview of parts and pieces of the OpenSciEd curriculum that involves student sense making. So we're going to begin in just a second thinking about sense making, but I want to invite you to just read over the goals for our short time together today. And if you just joined, please click that link and make sure you've got that resource page available. So today, we're only here for an hour. So we're going to do a little bit of reflecting about sense making. We're going to engage in a couple instructional strategies that go with the OpenSciEd curriculum. I've picked a lesson for us today. And then we're really going to focus on the instructional elements that really dive in and support student sense making in the OpenSciEd curriculum. So again, this is a snapshot, which means I'm not going to be able to tell you everything and anything, but remember, Activate has longer webinars that are going to go more in depth into the things we're going to touch upon today. So let's just make sure everyone has the resource page. If you have this page open and ready to go, give me some feedback in the chat. Type ready, give me a thumbs up, some kind of something that lets me know you are good and it's working the way I thought. Perfect. Thanks for that feedback. Wonderful. All right, we got lots of folks ready. Thanks for the thumbs up. Thanks for the informal feedback. All right, so let's just talk about what we're going to do with this resource page. For each of these webinars in this snapshot series, we are going to use some resources. Now, not everything out of these 11 we're going to touch on today, but there are some that I'm going to need you to open, to work with, to make a copy of, to help with our own sense making together in this space. If you're wondering about these slides, the answer is yes, you will have a link to the slides. It's right here, already ready for you to go. Here's a link to register for the rest of the webinars. We're doing 5 of these, and remember, it's just a snapshot. So we're not going to get into everything, but you're going to get a little bit of a taste of what student sense making is. So best idea is to minimize your Zoom screen, shrink it so you can see the screen, but also have this document maybe in another window so that you can see both at the same time. So hopefully everybody has this link and we're ready to go. And thanks for the feedback. As I go through our sense making activities here, you're going to see these number circles on the slides. What those correlate to are the numbers in the resource page. So when you go back and look at the slides, you've got a correlation to help you understand what's the resource Rebecca used at that point in time. So here we go. Let's get going on our journey. I'm going to ask you to go into what we call the alone zone, a metacognitive strategy that allows you time to think by yourself without the influence of anybody else. Critical for sense making, especially with students. Too often, we don't give kids enough time to think about their own thinking and commit to it on paper. So that's what I'm going to ask you to do. For 1 minute, we're all going to go quiet, and I want you to just reflect. What is student sense making to you? And I'll set the timer. What do you think this looks like in the context of a science classroom? And what needs to be in place in that classroom for sense making to be possible? So find a piece of paper, grab a notebook, and do some metacognitive thinking for 1 minute, because we will share on the next slide. So here we go. 1 minute to think by yourself. About 30 seconds left, and be prepared to share in just a moment. What is student sense making in your mind? time is up. So now that you've had time to think about your own thinking, now you are prepared to share. So on the next slide, what we're going to do is find the chat box, and we're just going to share some ideas. So find the chat and just open up and tell us what you're thinking at this point in time. What do you think this looks like in the context of a science classroom? What needs to be in place for student sense making to be possible? And basically, what is sense making? Come on in, find the chat. Let's look at some ideas. All ideas are welcome. Students engaging with what they're learning, comparing it what they know, and synthesize, making connections to prior knowledge. I appreciate your contributions. Explanations, working problem solving, absolutely. Making sense of concepts, asking questions. I see asking questions twice. Leaving a breadcrumb trail for discovery through inquiry. Great. We need time. We need materials. Yes, we need high quality instructional materials. Yes, we do. And we need think time. That is right about the phenomena. Notebooks, definitely a good structure. I couldn't keep up with those amazing ideas. So we've got great things: problem solving, application, hands-on, using notebooks, diverse sense making. Very good. So let's keep going. Part of one of the things that is involved in the OpenSciEd units are these routines. And we're going to walk through one of these routines kind of at a high level overview. So this is called the anchoring phenomena routine, and it is one of the routines out of the 4 routines that go with OpenSciEd that help with student sense making. So let's dive in. We're going to do a couple of the instructional strategies, and then other parts I'm just going to high level talk through. So here we go. Let's start. I want you to engage with the phenomenon soon, and I picked the one from Unit 7.1, Chemical Reactions in Matter. This is from Lesson 1. The beginning lesson, and this is actually 4 days total in the curriculum. So we're really just touching upon this very high level and doing it in about 20 minutes. So here we go. In the chat, what's cool about this is the anchoring phenomena has to do with bath bombs, which is super exciting for kids and is going to motivate them. So let me tell you a little story. Let's say a colleague got me something from the store, and it's called a bath bomb. I tried it at home and I found it did something pretty interesting. Have you ever heard of these before? What do you know about them? What are your experiences with bath bombs? So start in the chat with sharing this first bullet here. Have you heard of bath bombs? What is your experience with bath bombs? And then what do you predict will happen when a bath bomb I got from the store is put in a bowl of water? So take a moment, think about your own thinking about bath bombs and your experience, and then share some ideas in the chat. What's your experience? What do you predict will happen with a bath bomb if I put it in water? I can see all of you thinking very deeply, those of you with cameras on. Ooh, how big is the bowl? Good question. Think of salad bowl style, like a big family style bowl. Excellent question. Love bath bombs. What do we predict might happen if I put it in water? I heard of them. I've used them. It started to dissolve. They have bubbles. Ooh, you got some as a gift. It bubbled, changing color, fizzing. Ooh, say more about what fizzling is. Aqua sizzlers. That's cool. The bath bombs will dissolve. All right. So this part of the anchoring phenomena routine is we're just connecting to what we already know about bath bombs. And so if you're still writing in the chat, that's all good. I'm going to gently push us forward. There's a Hot Wheel inside. Oh, my God. Oh, man. Here we go. So now that we're kind of thinking about our experience with bath bombs, we've made some predictions of what we think. I think it would be fun if we put the bath bomb in water. Would you guys like to do that? Let's do this. So here we go. In your notebooks, 7th graders, I'd love for you to take out a chart or take out your notebook and make a notice wonder chart. Now, since we're in a virtual space, I did build you a virtual example if you would like it. Oops, I didn't mean to do that. Let's go to resource number 2. If you'd like to do this and you don't have a piece of paper near you, go ahead and click the Notice Wonder chart. It's going to ask you to make a copy. That way you each have your own one that you can write on. We are going to do this part. This is a strategy we are going to engage in together. So grab your Notice Wonder either on a piece of paper or copy the one I created for this experience. And when you're ready, either with your notebook, your paper, or the digital version, give me some feedback in the chat. Like I'm ready to go, thumbs up, some kind of feedback so I don't leave anyone behind. All right, Jennifer's ready. Other folks are getting ready. And if you just joined us, we are in resource number 2 in this link. So give me some feedback and here we go. Okay. So you're going to use that space to record what you notice. So your observations and then your wonderings, your questions about the bath bomb before and after we add it to water. So that's why I gave you these 2 sections. One section is for before we add it to water and one is after. I like to give my kids those lines of learning so that if we do a before, during, after, they know which of their observations was for each piece. And these did say before and after, but when you make a copy, it does something funky with the image I put in. But the image is there. You can see I wrote before, it's just not showing up. So that's okay. Use the top part for before and then after. And I do have a bath bomb right here that I'm going to show you. So if you can put your eyes on my camera, here's the store-bought bath bomb. And in class with kids, you would have them pass this around. Each kid gets 20 seconds to make observations and wonderings. This is before we add it to water. So now that you're ready, we are going to engage with the phenomena. So let's move forward in this routine. Here we go. And you're going to want to turn the volume up on your side, on your computer. So this video, every single one of the anchoring phenomena, there's tons of videos. OpenSciEd has videos for all of this ready to go. They're all on the YouTube channel. Here it is. Make sure your volume is turned off because observations are our 5 senses. I'd like you to use your sense of sight and your sense of hearing. And then as you watch the video, complete your notice and wonder chart. Remember, before, take some observations and questions, and then after it's added to water. Here we go. What do you notice? And again, the students would be touching it. And now we've added it to water. What are some things you see happening to the bath bomb? What are some things you see happening to the water? What kinds of observations do you hear? And with students, you would sit them around in a circle and have them all watch this at the same time, kind of like a fishbowl style. Yes, what do you hear? Observations are our 5 senses. So sense of touch, smell, taste, our listening skills, eyes. But since we're virtual, we can only go with sound and eyes right now. Do we see? What kinds of observations do you hear? And then let's close up our observations and make sure we have some wonderings. What are you wondering? Think about what was there before and to what you're seeing now. Continue your observations for about 10 more seconds. while I come on back. And then we will share some ideas in the chat. Okay. So finish up your thoughts, and I'm going to gently push us forward in our learning here. Now, since you've had time to think by yourself in the alone zone, that means every person has something to contribute to the learning of us all, because science is a collaborative endeavor. So providing that time to think in the alone zone is critical for equity and access. We all shared the same experience and we all had time to think. Now we have something to share and something to discuss. So find the chat box, and we're going to do a waterfall. If you're not sure what a waterfall is, here's how it works. Let's take question 1. We're going to do noticings first, before and after. What did you notice? I'm going to give you 30 seconds to type your ideas, and when the timer goes off, hit enter, and then all our ideas will waterfall down, and I can go and look for trends in our thinking. Then we'll repeat the process for our questions. So let's start with noticings. Find the chat box, drop some ideas in there, but don't hit enter until the timer goes off, which I know is a challenge. So, oops, I did not mean for that thing to get big. That's okay. All right, keep typing your ideas. And I'll turn off my camera for bandwidth just to make sure everything's good. No, I'm not sure what's going on with this timer, but let's pretend that it's working. There it goes. All right, let's go down to 20. Here we go. So right now you should find the chat, put some of your noticings in there. Try not to hit enter. I know it's very difficult. Get ready to hit enter once the timer gets down to 0. And then all of our ideas will waterfall in. 2, 1. All right, go. Ooh, before it was a compact ball. So go ahead, scroll through, look for connections to each other's ideas. I see a lot of people saying it used to be a ball. Now I hear bubbling and fizzing like soda. It's white, round. The ball existed. It was solid. The water's liquid, fizzing, bubbles. Lots of bubbles, fizzing. Ooh, the water became cloudy. And no worries if you're late. We're all in the space together, here to help each other. No big deal. Okay, so we saw some changes. It was round and solid, and then something happened, and fizzling and bubbles and sound, and then it wasn't there anymore. So I bet you're having some wonderings. What is going on with this phenomena? So let's repeat for wonderings now. Thank you for sharing and contributing your ideas to the idea pile. Here we go. Waterfall with your questions. What questions do you have about the phenomena? What does it make you wonder? What might be causing that phenomena to happen? What do we not know about parts of that system? The bowl, the water, the bath bomb, that could help us make sense. What questions will help us gather information about what's going on? Time is up. Come on in, hit enter. Let's see what you're wondering. Ooh, gas. I see some new words. Gas. Is there gas in the bubbles? What is it made out of? So we're wondering about ingredients. Is it a chemical reaction? Ooh, temperature of water. How do you make bath bombs? Would the bath dissolve it? Okay, I see a thread emerging. We're wondering about temperature here. Cool. All right, so this is just starting our thinking. We're not going to build our driving question board yet. We're just sharing our current wonderings. How will it make my skin feel? Does it have a strong smell? What is it made out of? Lots of folks are wondering about ingredients and the bubbles and gas. So let's keep going on our journey here in the anchoring phenomena routine. Here we go. Next, and I'm just going to go high level because we don't have time to do all of these. What happens next is the students are actually going to get 4 different kinds of homemade bath bombs. And if you get the kit, you can either purchase the bath bombs already made, or you can make them yourself, which is super fun. And everything comes in the kit, the recipes, the little trays to make it in. And so what the kids are going to do is look at 4 different homemade bath bombs in comparison to the store-bought bath bomb that we just experienced. And then you provide all of these supplies. So take a minute and just read what the kids are going to get. So you say, I have all these, materials for you. What types of observations do you really want to collect? And the kids are going to have all kinds of different ideas. Oh, I want to know how much it weighs. I want to know what it's made out of. I want to know this. I want to know that. And so this is one of those great kind of open investigations. And then what they do is they make observations of the 4 different ones before adding them to water. So they repeat what we did with the phenomena, and they use 4 different bath bombs: observations before, observations after. And so here's what they look like. So they use magnifying lenses. And then on the second page of their notebooks, what they do is they write about homemade bath bomb investigation observations. And what's cool about this lesson, the students get to choose which investigations and what kind of data they want to collect. So some students might want to work on mass and weighing this. Some students are worried about temperature. Some students want to research what bath bombs are made out of, right? Using those materials, though, is what they need to use in order to start gathering information. So this is one of those cool choice investigations. And so as we keep going in our journey, after they engage in those, and we're just going to pretend like we did that for our time today, what happens next is, now that they've had experiences with 5 different bath bombs, the store-bought and the 4 homemade ones, they're going to start to make sense. And sense making is about taking what's in your mind and making your thinking visible on paper. This is one way we provide sense making for students. First, what I'd love for you to do, if you want to use this document, you can. But if this doesn't have an editable version, but I did provide it for you in number 4. What I want you to do, though, is find some paper, draw these 3 models. So what we have here, and we're actually going to do this part, I want you to sketch out what happened to that solid bath bomb and where the gas bubbles appeared in the system. And by system, I'm talking about the inside of the bowl and all the substances inside the system. So you're going to show right before adding the bath bomb to water, then skip ahead in time, a couple seconds after adding the bath bomb to water, and then a few minutes later. So I'm going to give us 3 minutes in the alone zone for you to sketch out your ideas by yourself first before ever sharing with others, because that's how we build thinking classrooms and have students make sense of their own thinking first. That's that metacognition. What am I thinking? So I'll go quiet for 3 minutes, productively struggle, and draw your pictures. So here, think about what happened before. What did the bath bomb look like before? couple seconds after, what did the water look like? You can use pictures, symbols, words. And remember, you do have access to this in number 4 in our resource page if you'd like to see the actual student handout. Try to use symbols if you want, words, label things in your diagrams, in your models. You want to use colors, have at it, or describe with words. And we are going to move on in about 20 seconds. Finish up. Come on back together. And now we're not going to actually share our models just due to time constraints, but what the students would do next, I'm just going to walk you through and show you some examples. So here we go. Oh, actually, let's do this first. I forgot about how excited. I'm sorry. I'm so excited. Yes, let's do this. What we want to do now is we are looking at the macro scale. So I'm going teacher hat here for a moment. What we want to guide the students' brains into looking for are different parts of different systems. So what this lesson asks the students to do is to go to their diagrams and add in letter A, B, C, and D in different locations. So for A, a spot in the bath bomb before adding it to water. So here's an example, right? Here's a circle, represents the bath bomb. That I'm going to label A. B, a spot in the water right before adding it. So you can see here's a cup with some water. Here's location B. So follow these directions and label your initial models with A, B, C, and D. So we've got a spot over here and over here. And what this helps us think about is different parts over time of the system. Here we go. We're going to move on. So now what happens then is they have these ideas of what they think at A, B, C, and D, right? So we've got our thinking is visible, we're struggling, we're sense making. And now we're going to take it a step further because this drawing is at the macro level and we want to come down and zoom in to the micro level. That is why we need letters A through D. So we're not going to actually do this part, but what the directions in the teacher guide say is the students would go back in the alone zone for 5 minutes to think about their own thinking. And these little zoom on points are point A, point B, point C, point C and point D. And then we have this circle now for kind of like the before, then something happens, and after. And this is kind of getting at what do we think is going on from the before and after. So the students would get this handout, you would guide them. There's questions that go with it as well. And if you're curious to see this handout, it is number 5 in your resource collection. And then here we go. Let's keep going. And if you have questions, I'm going to try to answer them along the way. And here we go. So D is a tiny sample of the gas as a bubble. C is a tiny sample of the liquid over a couple of minutes. So we've got both the gas and the liquid. That's the difference between C and D. And I know it looks a little fuzzy, but if you want to see it, it's number 5. So then what they do is they have these initial model-based explanations. So I want you to think of this from the sense-making lens. When we make our thinking visible through diverse sense-making, writing, drawing, coloring, and then talking about it, this is how we make sense. So here's a little key. Here's an example. And what happens next in the lesson is everyone is going to share. That's why the alone zone is so critical, that independent think time. Think about your own thinking, productively struggle, make sense of your own mind first. Then you can share with others. So it's important to give them alone time. So now you say, turn your notebooks, you're going to be sharing. This is where you bring in your classroom norms, that great set of norms that OpenSciEd has. Then how we get kids to connect to each other's ideas is we give them strategies. So for example, place a check mark by the parts of your model that are similar. We're looking for consensus. So they look at each other's and notice, what do we have the same and where do we have differences? Because now our learning is about we collectively making sense of this together. So here's what I think, finding consensus items and then questions for what might be different. Not wrong, just different. And that's okay to have different ideas. So they share ideas, and then fast forward, once we do that, we're going to now ask them to consider related phenomena. Where else in their lives have they seen something similar? So this is what we call like analogous phenomena, these related phenomena in their lives that they might know of. So in the chat box, I want you to think about any other experience you have that reminds you of what you saw happen with the bath bomb. Other phenomena that might happen due to the same sorts of things that caused the bath bomb to do what it did. So find the chat box. This is open chat. When have you seen things do that? Ooh, pop rocks, bubbles and soda, Alka-Seltzer. Yes. Where else? What else might kids come up with? I appreciate that, Loretta. Baking soda and vinegar, pop rocks, Alka-Seltzer, airborne medicine, Mentos and Coke. Very, very, very common for kids to say that. Cool. Okay. So now that we've got some related phenomena, they make a list in their notebooks, prepare to share, just like we just did. And let's just move forward. And what else happens? So now that we've got a list of related phenomena, which we will come back to in subsequent lessons, but right now it's just what we're thinking at this point. We now each have these initial models that we've shared. And now that we've shared in small silos and groups, it's time to build our consensus as a whole group, right? So this is called moving into the initial consensus model discussion, where we as a class get together and make a whole group record combining all of the ideas we agree upon, figure out where do we have disagreement, and any new ideas we might consider. So here is a sample from a classroom on each of those ABCDs and what's happening and combining our ideas. So you work together to figure things out. Collaborative sense making. This is what we mean by sense making. Talking, writing, drawing, making sense, productive struggle, putting those pieces together with our class. And so what moves on from here, once we have our initial consensus model, now we still have these questions. And we're going to build what's called a driving question board. And we're actually going to do this right now. I'm going to show you a quick strategy. But this is the end of the anchoring phenomena routine. So now that we're going to, we've thought about our own thinking, we've come to consensus on what we agree upon and have disagreement, go back to your notice and wonder charts and look at your initial models. Look at our class consensus model. Look at our list of related phenomena. What questions might we still have? And so to do this, I'm going to ask that you all go to number 6, which is our Jamboard. So number 6, open it up, come on in, and I will guide your brains, just follow my lead on how to do this. Now you can do this digitally with kids. You can do it. OpenSciEd has a whole list of examples of different driving question boards and what they look like in the classroom. There's also Facebook groups for every single unit where teachers share ideas all the time. And so here's what I'm going to ask you to do. Go back and look at your notice and wonder. Think about related phenomena. Think about our initial model. We know that there's particles in here. We know there's particles in the water. We saw some gas particles. There were gases in the bubble. We had some liquid left over, but we're still kind of wondering what's going on. Did it break apart? How did the gas bubbles get there? Was it burping? Is there a reaction? Is it mixing? Is it a solution? Is it dissolving? So we still have a lot of questions. So come on into the Jamboard and let's start by putting one question in. Each of you put one question in. What are you still wondering that could help us make sense? So the Facebook groups are all OpenSciEd 7.1, OpenSciEd 6.1, whatever the unit name is the name of the group. Okay, so what I'm going to do, once you put in a yellow Post-it, and if you're not sure how to use it, just click this, hands off, leave it go, and I'm going to help organize our thinking into categories. So I see folks wondering what the gas is. Would it affect if they were different shapes? So where are the bubbles? Bubbles and gas I'm going to put together. What makes it fizz? Ooh, gas. We've got a category over here. Is something new created? And my job is to say, okay, you're all wondering about where did the gas come from? So I'll make a category over here. Here's questions about the gas. So keep coming in, put in your questions. I will help organize them into categories. What else are we wondering? Something new. What makes it fizz? What about dissolving? So we're wondering about the fizz. We got some fizz. This is the sounds. We're wondering about where that fizz and those sound are coming from. Ooh, temperature. Can you make bath bomb? Ooh, temperature. Two connecting ideas here. So we've got a new category. And what we're doing is helping group those questions into categories for future investigations, because student questions drive what we are going to do next. And our job is to finesse the conversation to say, do you all want to study blank next, and move them into the next lesson? Why does it not fizz? Ooh, you're wondering about fizzing. Ooh, someone wants to know about mass. Okay, and so you kind of get this process. It's about one question at a time. And so I'm not doing the DQB its justice, but let's review the protocol that does come with the curriculum. Here's how it works. The first student, you call on one student. Who would invite the students? Who would like to start off our idea pile? One question comes up, then that student is going to call on the next student. So whatever is related to this student's question, let's say they asked about temperature. You'd say, does anyone have a related question about temperature? And then when they raise their hands, the student who shared the first question calls on the next student. They read their question out loud, they place it right next to that student's question, and they start building categories, kind of like question chains. And you repeat the process. Who has a connecting question to this one? What category does this go in? Etc. until all the questions are on your beautiful driving question board. Now, this question board will sit in your classroom, either in Jamboard, on paper, on a bulletin board, on posters. And you're going to revisit it over time as you start to figure out answers to those questions. So this is about sense making, and this is called the anchoring phenomena routine. So let's just revise it. If you'd like the handout that goes with this, it is number 6 in your resource page. So we started with exploring phenomena with a common experience that does not rely on prior knowledge. It's going to motivate kids to want to be curious and go, what is causing that bath bomb to do that thing? So then, engaging in sense making, we start to use the science and engineering practices. You saw that through the modeling and the alone zone. Commit to your thinking first before sharing. Class consensus models. That's when we start using those science and engineering practices to make sense, which is sense making sense, conceptual understanding. Then we identified related phenomena, make connections between their own life, bring those assets in, use those assets to help us make sense. And then we develop questions which are going to drive the rest of everything we do and anchor our learning over time. We're going to revisit this thing as soon as we get some answers. That was just one of the routines in the storyline instructional model that's embedded in the OpenSciEd curriculum. So what we did here is the anchoring phenomena routine, which ends up in a driving question board, which then is going to drive us. We've got all these questions. Now we've got to figure out how to investigate using those questions. So we navigate we have navigation, investigation, then we put the pieces together. We have a problematizing, so we figured out some things, but we still have new questions that emerge. So you revisit the DQB, come on back, think of new questions, add them to the driving question board if need be, and we continue this process. So this is a process that promotes sense making and coherence, building upon building knowledge and repeating these routines so the students have ample time to make sense. So that is the anchoring phenomena routine that's at the beginning of every single one of OpenSciEd's units. But now let's take off our student hat, talk about why sense making. There's this great tool from the task annotation project, which is from Achieve, about sense making. And I'm going to ask you to read this in just a minute, but here's a great quote. Sense making is the glue. It is literally the binding agent that connects the three dimensions. So the SEPs, the practices, the verbs through which we perform, the core ideas, the content, and the cross-cutting concepts, the lens through which we ask them to think and gather evidence for specific aspects of phenomena. When students make sense of phenomena and problems, they demonstrate they understand these three dimensions. They also can figure out something in the world around them. So sense making is the glue. So let's go read this fabulous document. Number 9 in the resource page. Come on over, grab this document. I'll give us 5 minutes in the alone zone to read about sense making. And I want you to think of what we did and how it relates to sense making. So I will give us 5 minutes in the alone zone to read through this, then we will review it quickly. And think about the lesson I just did, a high-level overview, and how it relates to what you're reading in this document. And if you finish reading, just think about what we did in the anchoring phenomena routine and how it relates to what you're seeing in this sense-making document. Okay, about 30 seconds left. And then we'll chat about it real quick. And then we'll move on in our learning. All right, let's finish up our ideas or just text. All right. So let's keep going here. And so what I wanted to draw upon and connect with is what we did in the anchoring phenomena routine. So as you read, each dot represents one of the three dimensions, right? Blue are the practices, green are the cross-cutting concepts, orange are the content pieces or core ideas. So, but it's also representative of all the students' abilities and experiences that they've developed through these routines. And so we started with some phenomena. If you're in the engineering world, instead of beginning with phenomena, you would define a problem that you would solve through the engineering design process. So we've got this phenomena. We try to make sense of it. We put our ideas on paper of what we think, and then we strategically build our understanding and sense making through the use of the science and engineering practices, core ideas, and cross-cutting concepts. So over time throughout the unit, what's going to happen is sense making builds and builds and builds and builds, and we learn more and connect back to our questions. And hopefully by the end, we've got a lot of our questions answered and we can make sense of this very large anchoring phenomena through many smaller investigative phenomena along the way. As we gather evidence, we're going to get more of those pieces of the puzzle to help us make sense of the anchor. And so when we talk about the three dimensions, every single lesson in OpenSciEd has what we call the LLPEs, the lesson level performance expectations. That little taste that I gave you in lesson 1, here were the lesson level expectations. What we mean by expectations is three-dimensional performances the students engage of, starting with the verb, which is the blue practice, the green, which is a cross-cutting concept, always tied to the core idea or the content through which they're making sense. So sense making must happen in a three-dimensional way according to our standards and the K-12 framework for science education. So here's the three-dimensional lesson level performances for lesson 1. Now, what also is cool and really useful in OpenSciEd is assessments. Because our standards are so different, we must assess in a different way. So those older, more traditional style of assessments need to kind of be shift away from that rote memorization, very low level recall, vocabulary definitions, matching, fill in the blank kind of things that just really ask kids to recall information. How we really know about what kids know or don't know is through what we call transfer tasks, which means we're going to take another phenomena that has the same exact cause and figure it out and apply our knowledge. Now, our next webinar is on assessments. So if you want to learn more about assessments, come on back. We'll talk about the innovative assessments in OpenSciEd. But remember, sense making is the new way of teaching that's based on research of how people learn, which is from the framework of K-12 science education. In order to see what kids can know and be able to do, we have to transfer that knowledge to an analogous phenomena, something that has the same science reason causing it to happen. These are called transfer tasks, and they're sprinkled throughout the curriculum. As you saw in the TAPS document for Sensemaking, we've got to move away from the old way of assessing, which is multiple choice, one right answers, cookbook labs that have one right answer. Shift that from, that was just what we call learning about science. Now we have to make sense of science. So through modeling, evidence-based reasoning, arguments, investigations, etc. So because our standards are different and the research says we need to shift, your assessments should also look different. So again, one of the other cool things about OpenSciEd is they have these great tools called progress trackers, a thinking sense-making tool. So after certain lessons, you stop, you think, kind of like using a summary table where you go, okay, what was our question and what have we figured out and what evidence do we have? Then we go do some learning. We come back. What question were we trying to answer? What evidence do we have? What did we figure out? And then we build whole class sense-making discussions using the progress trackers to help us keep track of new discovering and things we figured out. So great ways. Now let's touch upon, for our very last moments together, on instructional elements that are already in the OpenSciEd curriculum that promote sense making. So for 4 minutes, I'd love for you to dive into the key instructional elements of OpenSciEd. This is number 10 in your dashboard here in your your resource page. Grab number 10. And then I'm going to give you 4 minutes to read through it, but here's the lens I want you to use. When do you see key instructional elements specifically calling out student sense making? And we'll share those after you're done reading. Grab number 10, alone zone time. We'll share once the timer is off. I see some people nodding their heads going, yep. I can see your brain's working. And one of the words that I want you to get used to is thinking about sense making means figuring out. Figuring out is a collaborative endeavor. We don't figure out the world by ourselves. So I want you to look for the words figure out instead of rote memorization, recall, low-level depth of knowledge. Sense-making requires multiple iterations, working with others, sharing ideas, connecting, building consensus. using diverse sense making, pulling upon kids' assets, repertoires, funds of knowledge, and using them. Think about what needs to be in place in your classroom to allow sense making to actually happen. And get your ideas ready. If you're already done reading, start typing in the chat. Get your ideas ready. Which key elements have you seen sense making? Providing ways for students to show what they know, productively struggle, connect ideas with classmates, build consensus ideas, discuss with others. And when the timer goes off, let's just share some ideas. Come on into the chat box and let's see, what key elements did you see sense making? Can be more than one, could be many. Where did we see words like figuring out and working together to problem solve? And due to time, lone zone is definitely one of those key strategies. So in the elements in this document, phenomena, does phenomena help us figure out? There it is. Coherence, building one lesson to the next instead of using random lessons that do not interconnect, and building conceptual understanding. Driven by evidence, collaborative, yes, definitely. We figure out the ideas together, and we will have multiple ways of figuring out together. So I want to leave us today with a quote, a couple quotes from the teacher handbook. If you haven't read this thing, it's amazing. This is number 11, but I'd like you to read what I have for you here. So there are 3 different quotes. Take a look at the first one. So all of our students come with funds of knowledge that we must draw upon and use as assets, as positive things to use in our classroom. Another key feature of OpenSciEd, multiple ways of knowing and discussing. We have initial ideas discussions, building understanding discussions, many different ways we make sense, because talking and writing in our own language, our own writing, is the way we learn. And finally, multiple modalities. We're talking about diverse sense making. That means using home language, drawing pictures, writing sentences, words, diagrams, symbols, anything to help us make sense is more than welcome in an OpenSciEd classroom. So just to let you know, we are having more webinars because we are at time. I want to thank you for being here. I appreciate your collaborative endeavor in the chat box. The next one we have coming up is on equitable discussion. So more about what are those discussion types. Then we'll talk about assessment. So at the top of your resource page, if you do want to register for more, I gave you the clicking link right here. And then thank you for being here. What you can fill out now, and I'll give you, is to get your certificate of attendance. Here you go. Here is your link. And so fill that out and it will automatically send you a PDF of your certificate of attendance to the email you use. So you don't need to ask me about it, just fill it out. And then it will send you your certificate to your email. And yes, this is recorded. Activate will be sending out the recordings afterwards. So thank you all for being here.